Hello, my name is Jaydeep Sai. I'm from BTech first year, CSC, and my topic is sustainable use of water. Water resources. Water resources are the natural resources of the earth that are potentially useful as a source of water supply. 97% of water on the earth is salt water, and only 3% is fresh water. Slightly over two-thirds of the it is frozen in glaciers and polar ice caps. The remaining unfrozen freshwater is found mainly as groundwater, with only a small fraction present above ground or in the air. Uses of water. Uses of water includes agricultural, industrial, household, recreational, and environmental activities. Water resources are under threat from water scarcity, water pollution, water conflict, and climate change. Fresh water is a renewable source, yet the world supply of the groundwater is steadily decreasing, with depletion occurring most prominently in Asia, South America, and North America. Although it is still unclear how much natural renewable balances this usage and whether ecosystems are threatened. Water rights. The framework for allocating water resources to water users, where such a frame exists, is known as water rights. Sources of useful water. There are two types of sources of water. They are natural sources of fresh water, artificial sources of usable water. Natural sources of fresh water. The natural sources of fresh water includes the surface water under river flow, groundwater, and frozen water. Surface water. Surface water is a water in a river, lake, and or freshwater wetland. Surface water is naturally replenished by precipitation and naturally lost by discharge to the oceans, evaporation, evapotranspiration, and groundwater recharge. Although the only natural input to only surface water system is precipitation within its watershed, the total quantity of water is that system at any given time is also dependent on many other factors. These factors include the storage capacity in lakes, wetlands, and artificial reservoirs, the permeability of the soil beneath these storage bodies, the runoff characteristics of the land is the watershed, the timing of the precipitation, and local evaporation rates. All of these factors also affect the proportion of the water loss. Human activities can have a large and sometimes devastating impact on these factors. Humans often increase storage capacity by constructing reservoirs and decrease it by draining wetlands. Humans often increase runoff quantities and velocities by paving areas and channelizing the stream flow. The total quantity of water available at any given time is an important consideration. Some human water users have an intermittent need for water. For example, many farms require large quantities of water in the spring and no water at all in the winter. To supply such a farm water, a surface water system may require a large storage capacity to collect water throughout the year and release it in a short period of time. Other users have a continuous need for water, such as a power plant that requires water for cooling. To supply such a power plant with water, a surface water system only needs enough storage capacity to fill in the when average stream flow is below the power plant's need. Natural surface water can be augmented by importing surface water from another watershed through a channel of or pipeline. It can also be artificially augmented from any of the other sources listed here. However, in practice, the quantities are negligible. Human can also cause surface water to be lost, that is, become unusable through pollution. Under river flow. Throughout the course of a river, the time volume of the water transported downstream will often be a combination of visible free water flow together with a substantial contribution flowing through rocks and sediments that underlie the river and its floodplain called the hyporheic zone. For many rivers in large valleys, this unseen component of flow may greatly exceed the visible flow. The hypoic loss zone often form a dynamical interface between surface water and groundwater from aquifers, exchanging flow between rivers and aquifers that may be fully charged or depleted. This is especially significant in Karats area where potholes and underground rivers are common. So it is about under river flow. Throughout the course of a river, the total volume of the water transported downstream will be often be combination of the visible free water flow and substantial contribution flowing through rocks and sediments that underlie the river and the floodplain. It is also called hyporheic zone. From many rivers in the large valleys, the unseen components of flow may greatly exceed the visible. The hyporheic zone often is a dynamical interface between the surface water and the groundwater from the aquifers, exchanging flow between rivers and aquifers that may be fully charged or depleted. So this is especially significant in Karat areas. The Karat areas where the potholes and underground rivers are common. Next is about the groundwater. Groundwater is a fresh water located in the subsurface pore spaces of soil or rocks. It is also water that is flowing within the aquifers between the water table. Sometimes it is useful to make distinction between groundwater that is closely associated with surface water and deep groundwater in an aquifer, sometimes called fossil water. So the groundwater is the most fresh water of the earth and it is located in the subsurface pore space of the soil and rocks. So we can find the groundwater below the ground and it is found below the pore spaces of the soil and the rocks. It is also the water that is flowing within an aquifer. So the groundwater will flow within the aquifer. So the ground will sink the water and it will be turned to the groundwater. Sometimes it is useful to make a distinction between groundwater that is closely associated with the surface water. So it is sometimes very useful to make the distinction between groundwater with surface water and deep groundwater is an aquifer. Sometimes it is also called as fossil water. Groundwater can be through of in the same terms as surface water inputs, outputs, and storage. The critical difference is that due to its slow rate of turnover, groundwater storage is generally much larger in volume compared to inputs that it is for surface water. This difference makes it easy for humans to use the groundwater unsustainable for a long time without severe consequences. Never, Nevertheless, over the long term, the average rate of seepage through the groundwater is the upper bound for the average consumption of the water from the source. So the groundwater can be thought of in the same terms as the surface water. So the groundwater can be also called as the surface water because it is found on the ground and the inputs, outputs, and storage. The critical difference is that due to its slow rate of turnover, the groundwater storage is generally much larger in volume as compared to the input that is from the surface water. So the groundwater storage is very large when compared to the surface water due to the slow turnover rate of the groundwater. These difference make it easy for the humans to use groundwater unsustainably for a long time. So this difference make the humans to use the groundwater unsustainable for a long time without several consequences. Over the long term, the average rate of seepage above a groundwater source is upper bound for the average consumption of the water from that to source. If the surface water source is also subject to the substantial evaporation, the groundwater source may be saline. This situation can occur naturally under endorheic bodies of water or artificially under irrigated farms. In coastal areas, human use the a groundwater source many may cause the direction of seepage to ocean to rivers, which can also cause soil sanitization. Human can also cause groundwater to be lost, that is, become unusable. Through pollution, human can increase the input to a groundwater source by building reservoirs or detention ponds. So, if the surface water source is also subject to substantial evaporation, groundwater source may be become saline. So, if the surface water source is subjected to the substantial evaporation, the groundwater may become saline, so it may become salty. This situation can occur naturally under endorheic bodies of water or artificially under irrigated farmlands. So, by the irrigation of the farmlands and endorheic bodies of the water, the groundwater can become the saline. In coastal areas, the human use the groundwater source may cause the direction of seepage to the ocean. So, the coastal areas, by the usage of the groundwater by the humans, it may cause the direction of the seepage to the ground ocean to rivers, which can also cause the soil salinization. So the this usage can cause the salinization to the soil. Humans can also cause groundwater to be the lost. So humans are using the groundwater more and more, which can also cause the groundwater to become lost, that is become unusable through pollution. So the humans are polluting, not only polluting the surface water, but they are also polluting the groundwater. Humans can increase the input to a groundwater source by building reservoirs or detention ponds. So the humans are increasing the input to the groundwater. So they are using maximum of the groundwater for the sources of building reservoirs or detention ponds. Frozen water. Several schemes have been proposed to make use of icebergs as a water source. However, to date, these have only been done for research purposes. Glaciers runoff is considered to be a surface water. The Himalayas, which are often called the roof of the world, contain some of the most extensive and rough high altitude area on Earth, as well as the greatest area of glaciers and paramost outside of the pole. 10 of Asia's largest river flow from there, and more than a billion people's livelihood depends on them. So the freshwater source is also a frozen water, which is also found by the icebergs. So nowadays the scientists are doing research for making the usage of the frozen water. So they are trying to purify the frozen water and making the water for the usage of the humans. But it is not for the general purpose. It is done for the research purposes only. Groundwater runoff is considered to be the surface water. The Himalayas, which is also often called the roof of the world, contains some of the most extensive and rough high altitude areas on the earth, on as the greatest area of the glaciers and paramost outside the poles. 10 of the Asia's largest river flow from there, and most than billion people livelihood depends on them. Artificial sources of unusable water. The artificial sources of fresh water can include treated wastewater, reclaimed water, and desalinated seawater. However, economic and environmental side effects of these technologies must also be taken into the consideration. So not only natural sources are there for the water, there are also artificial sources. Artificial sources of fresh water can include the treated wastewater. So the wastewater from our homes and industries are being treated to make the water used again and again, and the desalinated seawater. So the seawater is also desalinated and used as the artificial source of the usable water. So we are trying to make the seawater as a usable water. However, economic and environmental side effects of these technologies must also be taken into the consideration. So to make this water fresh water, there may be a chance of many economical side effects which causes the pollution again and again. So it is also our uh, technologies must be taken into the consideration. So we should also consider these technologies for the less pollution. Reclaim the water reclamation, also called wastewater reuse. The water reuse or recycling is the process of converting municipal water, sewage, or industrial water wastewater into water that can be reused for a variety of purposes. Types of reuse includes urban reuse, agricultural reuse, irrigation, environmental reuse, industrial reuse, plant potable reuse, de facto water wastewater reuse, unplanned potable use. For example, reuse may include irrigation of gardens and agricultural fields or replenishing surface water and groundwater, that is, groundwater recharge. Reused water may also be directed towards fulfilling certain needs in residence, example, toilet, flushing, business, and industries, and could even be treated to reach drinking water standards. So, reclaimed water. So, the water we use for the washing purpose and for cleaning for agriculture use can also be uh, freshened, and it can also be used again and again for the usage of the industries, business, and many other examples. Water reclamation, also called as wastewater reuse, and we can use the groundwater recharge for the water we use once can be sent to the groundwater recharge. And the types of reuse includes urban reuse, agriculture, environmental reuse, industrial use. So we can use them for the urban, agriculture, environmental, and industrial and plant potable reuse. Defect to the wastewater reuse, unplanned potable reuse. For example, reuse may include irrigation of the gardens and agricultural fields or replenishing surface water and groundwater, that is groundwater recharge. As I said, we can reuse the water for the groundwater recharge also. Reused water may also be directed towards fulfilling certain needs in residences. So the water we used once can be again used for the residences such as for the toilet flushings businesses and industries, and could even be treated to reach drinking water standards. So we can also try to treat the water so that it can be reached to the drinking water standards. Desalinization. Desalinization is a process that takes away mineral composition from a saline water. More generally, desalination refers to the removal of salt and minerals from a target substance, as in soil desalination, which is an issue for agriculture. Salt water, especially seawater, is a desalinated to produce water suitable for human consumption or irrigation. The byproduct of the desalination process is brine. The desalination is used as many seagoing ship and submarine. So desalination is a process in which the salt water or saline water is purified and it is made to the fresh water by the process called as desalination. Desalination is a process that takes away mineral components from the saline water. So it is a process in which the saline water minerals are removed and the mineral components from the saline water. More generally, desalination refers to the removal of salts and minerals from a target substance. So not only the removing of the minerals from the saline water, it is also removing the salts, as in the soil desalination, which is an issue for agriculture. So the research are done for to make the soil desalination for the usage of the agriculture. Salt water, especially seawater, is desalinated to produce water suitable for human consumption or irrigation. So the water in the seawater is purified and treated, and it is also desalinated to make the water suitable for the human consumption and also for the irrigation of the fields. We are using the seawater, which is desalinated by the byproduct of the desalinated process is brine. So the byproduct of the desalination process of the seawater or saline water is called as brine. The desalination is used on many seagoing ships or submarines. Sustainable development of water resource. Sustainable development of water resource refers to the reducing the usage of water and recycling the wastewater from different purposes such as cleaning, manufacturing, and agriculture irrigation in such a way that water demands of future generation are not hampered. So sustainable development of water resource refers to the reducing of the usage of water. So the sustainable development is done by the reducing of the usage of the water and recycling the wastewater. So we in this sustainable development we are using water uh, by less usage, and we are also trying to recycle the wastewater for different purposes such as cleaning, manufacturing of the things and material, agricultural, irrigation. So we are trying to preserve the water and save the water for our future generations. So we are trying to protect our future generations by preserving the water for them. Is called as sustainable development of the water. Social solutions. Water conservation programs are typically initiated at a local level by either municipal water utilities or regional governments. Common strategies include public outreach campaigns, dry rate water rates, charging progressively higher prices as water use increases, or restrictions on outdoor water use such as lawn watering and car washing. So we also have the social solutions for the sustainable development and the less consumption of the water. The water conservation programs are typically initiated at the local level by either municipal water utilities or regional governments. So the water can be protected by the municipal water utilities or the regional governments. If for example, if the in any area, if there is a lot of wastage of the water, then the charges for the water consumption should be increased, by which the people can uh, use the less water, and the restrictions on outdoor water use such as lawn watering and car washing. So in the car washing and lawn watering also, if we make the strict rules, then the water usage can be decreased and the water can be preserved. Household and domestic solution. Water saving technologies for the home includes low flow shower head, sometimes called energy efficient shower head, as they also use less energy. How? Low flush toilets and consumption toilets. These have a dramatic impact on the developed world, as conventional Western toilets use large volumes of water. So they are also having household and domestic solutions. So in the while we are bathing, we use the showers, which uses a lot of water, and the lot of water is wasted, by which the preservation of water is not done properly. So there is a solution for that. We can use the bucket of water instead of doing showers. And the Western toilets are using much volumes of water for the flushing. So it is we can change the our toilets. So these have a dramatic impact on the developed world, as the conventional Western toilets uses large volumes of water. Saline water, seawater, or rainwater can be used for flushing toilets. So not fresh water. We can use saline water or seawater or rainwater for the flushing of the toilets. Wastewater reuse or recycling system allowing. So the allowing of the wastewater reuse or recycling system, we can encourage the reuse and recycling of water system. High efficiency clothes washers. So the cloth washers efficiency should be high, by which the water can be protected and preserved and can be stored. Weather-based irrigation controllers. So based on the weather, the irrigation system should be made so that the according to the weather, the irrigation can be done, by which the water usage can be controlled. Use low flow taps in the wash basins. So we can see sometimes in some wash basins, the taps will be very pressure flow, and we can control them by arranging the low flow taps in the wash basins, by which the flow of water can be reduced and the water can flow can be controlled. Commercial solutions, infrared or foot operated faucets, which can save water by using short bursts of water for rinsing in a kitchen or bathroom. Pressured water brooms, which can be used instead of a hose to clean sidewalks. X-ray film processors, recycle circulation system, cooling tower connectivity controllers. Water harvesting can be undertaken through variety of ways: capturing runoff from the rooftops, capturing runoff from the local catchments, capturing seasonal flood water from local streams, and conserving water through watershed management. So these are about the water harvesting techniques by which we can control and preserve we can harvest the water. These are the ways by which we can harvest the water. Agricultural solution. The solution for the preserving the water by agriculture techniques. An environmental plan in combination with specific crop correction factors can be used to determine how much water is needed to satisfy plant requirements. Drip irrigation. Drip irrigation is also known as trickle irrigation or micro irrigation. It is an irrigation method which saves the water and fertilizers by allowing water to drip slowly to the roots of the plant, either onto the soil surface or directly onto the roots zone through a network of valves, pipes, and emitters. So there is an agricultural solution for the controlling the water usage by the process of drip irrigation. So in the name itself, we can see drip means a drop. So the irrigation to the plant by the drop and drop gives the by which the plants absorb the water slowly, and the water gets the sufficient water. The plant gets the sufficient water by which the over usage of the water can be reduced, and each plant get the equal water supply. Challenges and threats. Threats for the availability of water resource includes water scarcity, water pollution, water conflict, and climate change. So there are many challenges and threats for the preserving of the water. The threats include the water scarcity, water pollution, and conflict and climate change. Water scarcity. Water crisis in the lack of fresh water resources to meet the standard water demand. Two types of water scarcity have been defined: physical and economic water scarcity. Physical water scarcity is where there is not enough water to meet all demands, including that need for a ecosystem to function effectively. Arid areas, for example, Central and West Asia and North Africa often suffers from the physical water scarcity. So about the challenges is water scarcity. The water scarcity occurs when the demand is more and the water is less, and the physical water scarcity is where there is not enough water. So there is not if there is a not enough water to meet all the demands of the people, including the need for the ecosystem to function effectively. Arid area, for example, Central and West Asia and North Africa, often suffer from the physical water scarcity. The countries and continents such as Central and West Asia and North Africa are suffering due to the water scarcity. So these countries don't have the enough water to meet all the demands of the ecosystem. Management and governance. Water resource management and governance is handled differently by different countries. So the water resource management and the governing of the water management is implemented differently by the different countries. For example, in the United States Geological Survey (USGS) and its partners monitor water resource, conduct research, and inform the public about the groundwater quality. So the USGC and the partners are monitor the water resource. So they are monitoring the water resource and giving the awareness to the public and the people about the groundwater quality. I thank I thank the faculty and the college for giving me the chance for speaking about the given topic. Thank you.